what I plan to do is kind of keep this updated. Brief overview, I work in Cisco systems, so I'm also one of the Docker captains. So here in this session, right, I don't plan to cover basics of Docker networking. I'll just have one slide to just give like a very high level thing, but I kind of want to spend more time on the issues and tips and techniques, right? That's kind of what I want to focus on. But in terms of what is the ecosystem, right, of Docker networking, so we have network drivers. You have different kind of network drivers. You have a bridge network driver. You have a host. You have overlay. So I have next slide which kind of compares these network drivers. Then you have swarm networking, where you have multiple hosts, and you want to create a cluster. How do you network in a swarm environment? Then you have service discovery, where you have plenty of services running, and you want to kind of automatically discover the services. You have load balancing, where you have a service composed of multiple containers, and I want to load balance across the containers. And the last thing is encryption, right? I want my control plane to be encrypted. I want my data plane to be encrypted. So at a high level, I would say these are the 5 building blocks, right? So some of the terminologies I will use in the slide deck, right? Unmanaged containers. What I would mean by unmanaged containers or containers you run by Docker run. So that I call it as unmanaged container, because there is no orchestration to manage these containers. You start the container, you manage it. The managed services, or something that you create, Docker service create, that is something which is managed by Swarm. So that's what I call by managed services. So typically there's a lot of confusion about Swarm. So in this slide deck, when I say Swarm, it is a post 1.12 Swarm, where Swarm is integrated in the Docker engine. If you look at pre 1.12, Swarm was a separate component. All the examples that I've used in the slide deck are with version 17.06 and below. So as Ajit and Nitendra mentioned, 17.06 got released a couple of days back. And the last point is I have focused primarily on Linux networking. I don't know much about Windows. So at some point I'll see if we can update that. Okay, so this is at a very high level, right? How do you compare these different network driver types in the Docker, right? So basically, at the right side, right, you have all the driver types. On the left, I have the different features that are for these different driver types. I don't think I can.
No, I can't do that. It will be there after that. We'll put the slides at the meetup page. You can look at that.
Yeah, I'll see if I can do something later.
Okay.
From a connectivity perspective, right, you want connectivity between containers on the same host. You would use the first 3. If you want across the host, you would use the next 2. Second thing is about service discovery and DNS. With bridge network, which is the default bridge, you use links. I think people would have used this. Is the very first thing that when I want to link containers, this is the first thing Docker came with. In all the other types, you use the DNS engine that is embedded inside the Docker. So that is how you do service discovery and DNS. For external connectivity, for the first 2 you use NAT. For the host driver, you use the host gateway as it is. Overlay network by default doesn't provide external connectivity. The MAC VLAN, IP VLAN uses the underlay network. So there's a lot of examples I covered in MAC VLAN, IP VLAN. It's kind of good to know about this because typically when you go to production, this is one of the network drivers you would often use, because I already have my legacy network. I don't want Docker to run in its own network. I want my containers to connect to my legacy network. Then you typically would go with a MAC VLAN kind of a driver.
For example, I'm having 10 network on my
on your already
Linux. Yeah.
Yes.
I want to use IP address the same.
Yes. So that is the case where you want to use the MAC VLAN.
MAC VLAN. Huh?
Yes.
I can use the same network and
Yes.
I can connect anywhere from.
Anywhere from that container to your outside board as it is.
Okay.
Namespace, right? So with almost everybody has its own namespace when it runs. When I say namespace here, right, it refers only to the network namespace, not the process or anything, right? So host alone, shares the same network namespace. With the host driver, you use the same network namespace of the host. With all others, you have your own namespace. With swarm mode, so till 1706, swarm mode was only supported with overlay driver. With the release that came out 2 days back, you can use swarm mode with any of the network drivers. So that's like really good to have actually. It's one of the most asked features I would think. With encapsulation, so this one I mean by encapsulation is like what is the packets in the wire? If you look at it, how does it look, right? With overlay driver, you use a VXLAN encapsulation. With all other drivers, there is no encapsulation; it directly goes out. In terms of where how do you pick which driver you want to use for your application, right? Bridge driver you typically use for north-south access. That is like I want to access from internet my container, or my container want to access the internet. So that's typically where you use the bridge driver. Both bridge and user-defined bridge are in the same category. Host driver is I want to have complete, I don't want complete isolation. I'm okay with using the host network namespace. For example, you said, right, I want to connect to my IP address which is already present. I can use the host namespace there also, because there is no separate namespace that containers have. It can directly connect to your underlying network. Then you can use the host namespace. Host driver, sorry.
Host driver.
Yeah. And MAC VLAN network is where you get isolation, but you can also connect to your underlying network. So that is where you would use the MAC VLAN driver.
Namespace is MAC VLAN is separate from the host.
Yes, it's a separate namespace.
It's part of the same network.
Yes. Okay, so I kind of classified this into 3-4 categories, right, of use cases. So I kind of try to run through fast, but whenever you want to stop, right, I can stop more. So first thing is like, I want to access my Docker daemon remotely. So if you have a Docker engine running in a host somewhere, and you want to use a Docker client from some other remote location, and I want to access the daemon. So typically you would use Docker host. Docker exposes its Docker engine on the 2375 port. I can set the environment variable like this, and I can use Docker CLI. It will connect to the remote host and automatically access it. Now, obviously, that is not secure because it's in the open. It uses regular HTTP. If you want to use it secure, use port 2376, which is your HTTPS mechanism. Now, the problem is if you want to use this HTTPS, you have to set up your keys, SSL keys and everything, which is a little bit more tricky. Typically, people have an SSH access. Let's say you have a Docker engine somewhere, you will have an SSH access already set up. I like this way of doing it, where you tunnel your 2375 connection over the SSH. So this is the way you can do it. You use the same encrypted, SSH already uses encryption. So why don't we just use that rather than setting one more secure channel? Yeah, so this is at high level on the access side. Now this is one problem typically I face and many people would face. I want to run Docker behind my corporate firewall, right? Obviously you have all the proxies and everything set up for your access. I start to run Docker, I cannot pull the images, I cannot build it. This is the very first problem everybody will hit. There are two kind of proxies you need to set up. The first proxy is to allow docker.io to download Docker images. The second proxy is for building containers and allowing the containers to access the external world. So these are the two proxies that you need to set up for when you're behind a corporate firewall. Okay, so the third one, right? Docker networking with VirtualBox. I think I'm pretty sure everybody would have used VirtualBox. When this is the first you use Docker Mission, and you would have used VirtualBox. There is a bunch of problems you would face when you are using VirtualBox. So I've run my web server. Okay, before that, right? How does VirtualBox work, right? When you have VirtualBox and you run Docker, there is a small VM that runs, which is called as a boot to Docker VM, on top of which you run your containers. So the containers are not running natively in your host machine. There is a small VM. So let's say I run a web server in my container, and I want to access that from my host machine. So you would not be able to do that, because even if you do -p and you say 8080, that 8080 will not be accessible from your host machine. It will be accessible only from the small VM that you have. Now the easier way to do that is to configure port forwarding inside the VirtualBox, where you can export the ports that are in the VM to your host machine. So that way you can access the ports from the host machine. The other thing is the second use case is like let's say I'm running some database or something which I'm running in my host machine. It's not containerized for whatever reason, right? It's a legacy application I'm running inside my host machine, and I want the containers to be able to access this legacy application which is not containerized. So the way you could do that is you can, depending on whether you use a NAT or a host driver inside the VirtualBox, you can use the gateway of the particular driver of VirtualBox and run your service in that particular IP address, so that your container that is running inside your boot to Docker VM can access the particular service which is not containerized and running in the host machine. And this IP address itself would vary. It's your gateway IP address. Choose that appropriately, but you can do that. The last one is okay. So this is specifically if you want to try Mac VLAN with VirtualBox. Make sure you enable promiscuous mode turned on. Actually, otherwise, the two hosts will not be able to talk to each other. Some things which you learn the tough way actually. Okay, this is something I don't know how many people would need it, but I've seen that some people ask this kind of question. Typically, when you run Docker, right? This applies mainly when you're running on Linux, right? So IP tables is Linux way of maintaining the firewall rules. Docker goes and modifies these firewall rules so that it can do proxy and it can do NAT and all those things. There are some cases people don't want Docker to do that. If you don't want Docker to do that, there is a way to disable it. If you disable this, you have to make sure that you have some other way of providing network access for your containers. It's just something good to know actually. Okay, so this section of it contains more like on the container networking side. So this is one use case I'm pretty sure a lot of the enterprise companies would want to have, right? I don't want my containers to access the internet because you don't know what people would do with that, right? Very simple, right? When you create your network, you specify option internal. So that would prevent your container access to the internet either way, either direction. There are more options, like if you want to prevent inter-container connectivity, if you want to complete disable forwarding itself, there are different options that you can do actually. Basically, the reason I put this in here is there are ways you can control the network access, and Docker provides enough ways to control it. Okay, so this is about, let's say that if you want, think about this example, right, where you have a container and you want to talk to two different networks. What is an example, right? So I have my application container, which wants to talk to a front-end container, which is a web kind of a container. And then it has to talk to a backend, which is a database, which means I need to have two different networks that this container has to be part of. So again, this is something I found it the hard way. So when you do Docker run, when you give a network, right, you cannot specify multiple networks. You can specify only one network when you do Docker run. The same with Docker service also, right? You can specify only one network. The way you can create multiple networks is you have to do a network connect. So after you do a Docker run, you have to do a network connect. Here you can specify many services, many networks you want. And the reasoning also I have put here actually, again, if you look at one of the GitHub issues, they have mentioned this. The Docker run has many options. So some of the options are specific to one network. There is no way to group them. So that is the reason it's kind of more of a CLI issue, right? So so if you want to connect to multiple networks, you have to do it in 2 steps. You cannot do it in 1 step. So I kind of covered this before, right? Linking containers using the link option is really legacy. So this was like 2 years back. This was the first way to have 2 containers to talk to each other. I would say don't use link at all, unless you have some old application which is using link. There are much better ways of if you put 2 containers in the same network, you can achieve the same thing what link does and much more. So I also put here what are the disadvantages with links, right? a lot of you folks might already know, right? But don't use links. So just to give an example of how you would do this. So in this first example, right, there are two containers. We have WordPress and a MySQL. If we have to do the old way, which is the link way, I would link it to the MySQL container. The new way, you put MySQL in the backend container. You put WordPress also in the backend container, so they both can talk to each other, and they can use the same name itself. Because that is Docker automatically provides service discovery. All that you need to worry about in the old way. In the new way, it's much more simple.
New way is like create a network, and for both we are setting network as backend.
Exactly.
If you are running outside form, still you get the service discovery.
Okay, so here the service discovery is provided by the Docker engine itself. So native using
On the same box.
the same box. So here the assumption is on the same box.
So by default, which driver it will use?
So by default, it uses the bridge driver.
So same host. Right?
Same host, yes. Okay, so this is something you might not normally need it. So, but again, there are many use cases for doing this. You have a container that is running. Inside the container, you want to spin another container. A typical use case is you have a Jenkins. Typically, people use Jenkins for different things. One of the purposes could be building a container. So Jenkins runs as a container, and I want to run another container from Jenkins, and I want to build and run another container from the Jenkins. So the way you do this, I think it's kind of was even covered in one of the Nipendra's thing, right? So you basically volume mount your host Docker socket to your container. So if you do this, so this is Jenkins, and here I have volume mounted Docker.sock, right? So when you run new containers, the container runs on the host machine. So it doesn't run inside the container. So from a hierarchy perspective, right, if you look at it, your Jenkins container and all these other containers are in the same hierarchy. So which means they can talk using the same bridge network or Swarm or whatever, right? But they are in the same hierarchy actually. So because they are created on the same host. It's not really Docker in Docker. Docker in Docker actually is used for a different purpose, but this is not Docker in Docker. Okay, so this is another interesting one actually. In Docker, the host name is not used for service discovery. What is used for service discovery is your container name or service name. For example, right here, there's an. So I'm running a container to say there is a name is web, host name is web server. So that is the first one. Second one, name is client, and network is front end. So here we can access the web server by using the web, but not by the web server because web server is the host name. Typically, people think of host name is used for service discovery, but for whatever reason, Docker has done it in a way that container name or service name is used for host discovery, not the host name. Aliases, right? So typically, there are cases where you would want to have one container or service to be referenced by different names. There are many use cases to do that. Just if you look at, don't ignore the text part of it, right? But if you look at this picture, so there are three levels. There is a client, there is a WordPress container, and there is a MySQL container. So I want to reference this WordPress container as different names. I kind of want to reference the WordPress container as WordFront, and then the same container I want to reference it as WordBack. So the aliases that you give to the containers or network scoped, so that if it is in this network, I can use this alias. If it is in that network, I can use a different alias. Yeah, so let's skip this. So the next part is about, so till now we have mostly talked about settings which are at the Docker daemon level or at the container level. So here I will cover more like on the service level, like service level networking. Okay, so this is a problem which you will normally hit. You're running a Docker Swarm in the cloud, and typically you would see, oh, the Swarm nodes are not able to talk to each other. They are not able to form a cluster. So the first problem would be that there is a bunch of ports that are used for communication between the nodes. For example, in Swarm, there is a Raft management plane, there is a control gossip plane. So they use different TCP and UDP ports. So make sure that you expose these ports in your firewall. Whether you're running in the cloud or if you're running on nodes, these ports should be exposed. Otherwise, the nodes cannot talk to each other. Okay, so this is a case where till you have 1.12, that is where Swarm got introduced. Before that, people used to have regular containers, right, without services. So you would have cases where I'm running a container and I want to connect that container to a service. So there are many use cases for doing that actually. So I put some of the use cases. Either it could be a legacy application which is already running, and I want to connect to the new Swarm service, right? Okay. Okay, skip this because it's more complex, but I'll talk about this particular case actually. Okay, so here I have so I have a service which is called as a web, which is so whenever you see the service, right, it is using Swarm. So think of service as Swarm, right? And I have one more container which is not using the service. I'm running this as a legacy Docker run. Now I want to connect these two together. So that is my goal here, right? So the way you can do this is when you create this network, you give this attachable option. So once you give this attachable option, you can connect services and containers together. So here the network is same, network ONet A, so the network is same actually. But you just need to do the attachable option that allows the service to connect to containers. Okay, so this is a little bit on the complex side, right? So this is more of once you start going to production, right? You kind of would realize this. See, what happens is when you do bridge driver, when containers talk to the outside world, the source IP of the containers is not actually taken to the outside world. When you use NAT, the source IP gets changed. So when you have a container running and you have some application which looks at the source IP to kind of, let's say, classify the containers. This could be like a monitoring application. If you have different containers, it will think all the source IP is the same and it's going to get confused. So this is a problem with bridge driver where source IP gets modified. There are many use cases where people don't want the source IP to get modified. Now, at least I found two ways to solve this. One way is using IP alias. So what you can do is you can create, you have a single network interface, create multiple IP addresses, and have each container respond to a particular IP address. So if you do that, each container would use one of the alias IP address. So that way that IP address would be unique for that container. So this is one way to solve it. The other way to solve it is using the Mac VLAN driver. So that's kind of we talked about where you can use the host, not the underlying networking IP addresses as it is. So if you do that, then container IP address would be preserved to the outside world. So I'm running through this fast actually. Slides will be there and I can discuss that later as well. With regular Docker services, right, you use something like a routing mesh. So routing mesh is what allows load balancing inside the Swarm cluster. One of the problems that folks faced is, this is the reverse of the previous problem. In the previous problem, the source IP of the container gets modified. With routing mesh, the source IP of the packets coming in gets modified when it reaches the container. So I have a container running and I actually do not know the source IP when it comes to my container. This is specific to routing mesh. I have a link here which talks about why it is done that way. It's one of the I don't call it Linux kernel issue, but it is the way in which IPVS is implemented in the Linux kernel. The source IP gets modified. So if you don't want to do that, if you don't want the source IP to get modified, use something called a publish mode host. So when you create a service, here you can do publish mode host. The default publish mode is ingress, which uses the routing mesh. If you don't want the ingress publish mode, use the host publish mode. If you do this, source IP will not get modified when it comes inside. Only problem with this is load balancing will not be done by your Docker Swarm. Then you have to take care of the load balancing by yourself. But I see a lot of people using this for a lot of use cases. So I think, yeah. So I'll skip this for the lack of time. Okay, this is something good to know actually. There are two kinds of load balancers that are available inside the Docker Swarm. One is the default, which is the routing mesh, which uses layer 3, layer 4 based load balancing. But if you want to have application level load balancing, use something called as a HRM, which Docker provides it. It's called as HTTP routing mesh, I think. If you, this is not available in the community edition. It's available only in the enterprise edition. So the options available to you are either use the enterprise edition or use your own HTTP load balancer, which can serve the same purpose. I'm not sure if there is any plan for the CE to have, HRM. At least I haven't heard anything like that actually. Okay, so this is the new feature that came in a couple of days back, right? So till now, when you had Docker service, you only can have overlay network. You could not use bridge, you could not use Mac VLAN, you could not use host. So that was a big restriction. Now with 1706, you can use services managed by Swarm, and you can use any other network driver. So that's like I would say it's a big thing for 1706. So troubleshooting, right? So how much time we have? 10 more minutes. Okay. Yeah. So troubleshooting, right? So I think these commands pretty much most of you would have done it at different points, right? But I think these are pretty powerful, I would say, actually, because it has all the informations. The inspect, you can do inspect at different level. You can inspect a container, you can inspect a service, you can inspect a network. So that gives you like, what is the IP address, what is the aliases. It has all the information, and you can do like, powerful filtering and stuff like that. If you are looking for a specific information, you can get that. It's pretty powerful actually. Okay, so this part is something you would have to know actually. This is the way to debug containers, I would say. See, one of the big problems that we do when we have, right, the containers or have a specific application, right? So you have a web server, you have a database. So containers, just you make it as minimum as possible, right? In terms of what goes inside the container. We are all used to different debugging tools, right? We are used to ifconfig, we are used to TCP dump. All these kinds of different networking tools we have, not just networking debugging tools, even like, you have like, kind of a storage debug tool, right? Any of the regular Linux troubleshooting utilities. So how do you troubleshoot containers and services, right? The best way I would say is use a container, a troubleshooting container itself to debug containers. So I use this, there are a couple of more options available in the internet. So what you can do with this, right? So basically this particular container has all the debug tools installed inside the container. So what you can do is connect this container either to your host machine or to your container, and then you can use any of the tools available inside this. So just to give an example, right? So let's say I have a bunch of containers that are running in my system. So if I do this, right, when I do docker run, and here I specify the container ID I want to debug. And here, this container is my troubleshooting container. So once I do this, I connect to the network namespace of this container. And if I do TCP dump here, saying on port 80, which means that I want to look at packets reaching this container on port 80. So if you have a problem like, why is my container not responding to the web request, right? Now, the easiest way is I would debug this is first look at whether port 80 receives the packet, right? And obviously, when you start the container, I say, oh, I don't have TCP dump inside my container. So use the troubleshooting container, then you can get it. So this example is like the same thing. Assume that there is a problem with your VXLAN connectivity, right? Maybe you did not open up your Swarm ports. Now, how do I debug it? Is it a host problem, port problem? What do I do, right? So you run the troubleshoot container in your network namespace, and then you listen on this VXLAN port, see that, is there any traffic going back and forth, right? Then you can debug, okay, there is a host level issue that is, present here. This last option is like you want to go to the I don't know if how many of you are familiar with NS Center tool. This is a tool typically you would use when you want to get into a network namespace and debug much more detailed about it. But this tool also provides this, where you can run this tool and you can get into your a particular network namespace. So I have mounted this from the host, and then I can run this tool. So I can go inside that and debug more about the network namespace itself. Okay, there's some references here. See, what I can do is I was also thinking of doing a demo, but rather than a demo, I think I'll take a couple of questions. I think that would be much more productive. I think. If you have any questions, I can take.
So let's say if I want to do a HDR of my content, so present ingress, does it support, or how is it doing?
You want to do which one?
Data recovery from a container. So one container will always be active into the present cluster, and other will be in a standby mode. Okay. So if I want to bring that standby container to act as my active container. Okay. So present ingress is it supporting, or
no? That would not support, because that's going to load balance to all your containers, active containers.
So not like a single container that I can do.
Yeah, you cannot do something like an active standby. That's what you kind of want, right? Yeah. No, I don't think there's a way to do that. Maybe you need to have some kind of a wrapper on top of it to do by yourself. Let's say one of the way you can do it is like you can have your own health check, and then you do a switchover. Maybe Docker will do it, but at this point I'm not aware of such a functionality.
And also, like, can I specify any load balancing policies inside my ingress when I'm working on it?
No, the only load balancing is the default round robin load balancing. If you use the HRM, you get much more, but that's not available natively in C.
Regarding the corporate firewall,
okay.
So we were doing that. So we were able to connect, but when the request we used to pull the image, it used to get stopped by the proxy because of some certificate error.
Okay.
We have this solution. Because we have not been able to.
Maybe you can send it to me offline. I can look at that. Because we had faced this problem and now it's working. I don't remember this specific, but we had to do two kind of proxies actually. So
proxy we were able to fix.
Oh, okay.
We identified way to update.
Okay. So do you get a problem when you reach the server or external access from your
internal access?
Okay.
We were able to run the Docker search command.
Okay.
We were getting the search result. But when we were pulling the image, that time it was comparing the certificate and
okay, maybe we can look at it often.
And you were talking about some legacy network. So,
correct.
The networking team also have to upgrade to some latest network technology.
No.
To match with the.
No, the thing is, when I mentioned legacy network, right? I wanted to say that you already have applications running in your legacy network, which has some IP address space, right? And I want to run that to my new services that I'm installing. So it doesn't, see, the thing is, if you can convert your legacy to the new way, right, I can use the same overlay network to talk to it and stuff like that. The problem here is, since I don't want to convert my legacy containers and networks, I want my new services to be able to talk to my legacy services. So that is the reason why this kind of network driver is more convenient for legacy applications.
So the case where you showed you were connecting a legacy application with the service.
Okay.
That also gives you a service discovery.
Okay. Okay. So no, it would not actually. So because legacy application doesn't run as a container.
The case you showed, it was running as a container. You had a Docker service. You had something.
Oh, yeah, okay. Yeah. So that actually, I don't call that as a legacy. So there, it is more of a unmanaged container and a managed container. Yeah. So there, you're right. Their service discovery works. Yes. The case is the other regular pure legacy. Right? Yeah.
I think any more questions we can do it. Right?
Sure.
Take it offline.
Yeah.
If you are there for some more time.
Yeah, sure.
So the next speaker.
Okay. Thank you.
I think people were
were asking, some of you were asking about the slides. Usually, Srini, you share it in the Meetup link itself. It will be in slide that the link usually will be shared in the Meetup group. Thank you.
Hi. Am I audible? Okay, so I'm Ratnesh. I work for HP, and I've been part of this meetup for almost 2 years. Been actively joining the meetups, and this is the first time I'm presenting. Okay. And I'll be talking about Docker multi-stage builds, and this is one of the most awaited feature from Docker. We'll see why. And how many of you are already using this feature? If you're building from source code and shipping it in a Docker image, it'll be helpful. It will solve my problem. So, I'll start with the basic Docker build. So, usually it builds images from a Docker file and a context. We'll see what's the context. And context can be specified as a path. And the build process can refer any file or folder in the context. So the idea remains the same for multi-stage also. This is a regular build, but idea remains the same, but it is extended slightly. That's the difference. Okay. And I think the other 2 points are already familiar. Each directive in a Docker file creates a layer, and each Docker file generates an image which contains multiple layers. So I just create one image. I have a Docker file here. Build command using Alpine as my base image. Yeah, everything goes fine. I'm just very quickly interested in the first line. The message comes here. I'm not able to, sending build context to Docker demo. So what happens here is, I'm mentioning my context as dot present directory. So the Docker client transfers the whole directory to the Docker daemon, and now it has complete access to any files in my present directory. So based on the directories in my Docker file, there's a file mentioned, say add, it gets included in the Docker file. Sorry, it gets included in the image. That's how it works. Clear? Now, next part. So some of the best practices, like avoid installing unnecessary packages. So unnecessary package means more series, the possibility of vulnerabilities, and we have to fix it and send the image again. We run into all those issues. And each container should have only one console. I mean, Docker is designed to do that. It is supposed to only run only one particular process and minimize the number of layers, keep things simple. I mean, I make it as readable as possible, and of course, minimize the size of the image. Smaller the image, I mean, everything moves faster. Deployment, each phase, everything moves faster. Everything moves faster. Now,
the typical size of the image is?
I've seen from 3 MB to few
3.5
GBs.
MB almost.
Less than 1 MB. Hello.
Yeah, if you're including a doc, if you're using a base image as Scratch, specifically for Go binaries, then your image size is as good as your binary size.
But we don't see 1 GB and all, even a basic Java.
It depends on what you want to include, right?
No, we have just taken the default.
Huh.
They have default. And built a basic Java application. Then it was saying, now we don't know how to.
That could be solved in multi-stage maybe.
Yeah, so yeah. I can help you in reducing size. Yeah, probably we'll see that later. And so I have an application which is, you can have Java or React.js or Go or anything. In my example, I have a Go binary, and it's a statically linked binary. So it's simple. If it had been Java, then say I have to have JDK to compile it, and then in my image I need to have JRE to run it. Since it is Go, I just need the binary. Okay. So this is my intention. I just need to ship my application in a Docker image. Let's try it. So this is what it does. My Docker file does. So I'm getting base image Golang 1.8.3, which has my compiler, and then I'm adding my source code to the image. Yeah, I'm setting the work beer as my source directory. Then I'm running the compiler, and it'll give me a binary called app. And I'm setting the entry point as the same binary. Let's see what happens. Call it single stage. So it is pulling Golang image now.
But add SRC, what that line, what it will do?
Okay, show you the.
What PDA? No, actually, I never used that.
Okay, so add here, add set folder to the image. Okay, and work here, once I set work here, all my commands will run as if this is my present directory. Okay, it's taking a little longer than expected. So yeah, so this is a single stage build where I'm doing my compilation, everything, and I'm attaching the binary to the same image. So which means that my intention was originally to have only my binary as a part of the image. And if you look at it, I have my compiler, yeah, and all associated things like things to run, test, etc. In this case, I have only compilation, but there could be cases where I'm running test and generating some reports, code coverage, etc., etc. And consider if it was Java, and it have JDK and Maven. So Maven, from the moment you start a Maven build, it will download all the dependencies. Yeah, and will package everything into my application, which is not necessary. It'll unnecessarily blot up my image size, like somebody is mentioning, right? So that is one thing, and people have. I mean, they're always looking for solutions from Docker, and so far it has not come. I mean, just came actually. So, and in between they have used their creativity and found how to work around this problem. I'll show you that shortly. Just waiting for this to get completed. This is required for my next steps as well. So meanwhile, are there any questions?
This is one of the problem of having big layers.
Ah, yeah, true. Otherwise, it will happen in parallel.
Instead of adding that source, we can even check out, right? Inside the email,
Yeah.
check out the source from source control.
It can be. I think there's a way you can mention the repository itself. As a context, right? I gave dot. Instead, you can mention URL.
For that, we have to install that SVM. You have to install it.
Git. I don't know whether SVN is supported. Git is definitely supported.
What also will work in Docker file?
Yeah, that's what I think. You can context. You can mention URL. So finally. You can see the size of the image. It is 702 MB. So I'll do a Docker history on that particular image. Docker. You can see a lot of layers which are like 8 days old and 10 days and all. So whatever I add is just 54 seconds, hardly 3 or 4 layers. So that's what I'm shipping this. History. So there could be things which I need or I don't need. Being a static, I mean, being my binary is a statically linked binary, it doesn't require anything. Even I can use Scratch as my base operating system. So actually not required now, but in this case I had no choice because it was a single stage build. Now people have worked around this. So this is where I landed up. I want to ship only this. I ended up in giving all these things in my image. Okay, so there is something called a Docker build pattern. This seems to be the most popular workaround. This is like use 2 Docker images, 2 phases. First one, have a compiler, compile, and then keep the binary. Then next step, extract the binary out of that image, and then have the next Docker file. Have a minimalistic operating system like Alpine. Include only my binary. Done. But there are multiple drawbacks. Say you have React.js and Java in your source code. You will have multiple stages. Yeah? You will have a third Docker file here. First you compile React, then you compile Java. Then you actually create an image which will be a production image. Right? And you need to have an additional workflow joining all these things, all these 3 Docker files, build in sequence. So Docker says that the term used here, self-consistent. Docker files has to be self-consistent. It should be using only the context and the Docker file, and should not use anything else. That's a design philosophy. Doesn't work here. So there are other options also to solve this problem. How we have done it is we have used Docker volumes, I mean, mounts. I have source code somewhere on my host machine, mount it, call say JDK container, compile it, and once the compilation is over, run my final Docker image, Docker build command, which just includes my binary in the Docker. This is one other approach. Works well. So, I mean, it's almost the same. So I'll show this as well. Yeah. So I have the workflow. I've done it using a script. Step 1. I have a Docker file which is I call it .f. it does compilation. It doesn't add my binary to that image. Second step, create a container out of the image which I created in the previous step. Third, take out my binary, put in the host file system. Next step, create my final image, which adds the binary to image. I mean, my final filter. I'll show those files as well. This is my dev image. It is only my dev tools. This is only compiler. And after the compilation, then it exits. Next is the provision one. Getting LP. It's hardly 3 MB or 4 MB. Just adding the binary which I extracted from the previous image. Set as a
You could have used Scratch here or what?
we can as well use Scratch. Scratch might be confusing for some people, that's why I avoided it. Okay, I've run the build script. Done. Here my image is called final. See my image size is 5. So this works well, solves the problem, but there are other issues like I use a shell script. As long as the shell script works, everything works fine. If I change something, I put in a different environment, or I'm not aware of this flow, I take only one Docker file out and try out, things won't work. Okay. So finally, Docker has come up with, so it doesn't run anyway. Everywhere. Docker says build ship everywhere, so it doesn't work here. So finally, Docker has come up with a solution. It came in 1705 release. It's called Docker multi-state builds. So what they've done here is they've extended the from directive and the copy directive. Okay, and now Docker files can have multiple from directives. I'll show a sample. Just give you the how it works, and then I'll show you a sample. Okay. And each from statement is start of a new context. When we started the first build, we saw that sending context to Docker daemon, right? There was only one. Now we can have multiple ones. And advantages, the other feature which enables this, you can copy any previous stage to the current context. So say I have two contexts. One is my build tools context, where I had my dev tools, and second is my final. So now from final, I can directly access the previous context, the dev tools context. Like the way my directory was visible to the daemon, now the previous images directory structure is also available to the next stage. That's how this problem is solved. Like the way we saw in the previous build.sh. Instead of extracting, now the current stage can directly access the binaries in the previous stage. Got it? Clear, right? Okay, so when we started the first simple single stage build, we send the whole directory structure to the Docker daemon, right? All the files are available, right? Now with the multi-stage, we are keeping the previous images folder structure as the same context. It's available. So my first stage was compilation. Whatever compiler output is available, it is available to the next stage as well. Okay. Okay. And yeah, the final from directive, we have multiple ones. The final from directive creates a final image. Whatever was created before that, all that is intermediary and gets it's not used. Okay, and the from syntax also has a ask keyword. You'll see that. This is my new multi-stage Docker file. You can see that first line as built. So I'm giving a name to that particular context. Can as well leave a number. By default, the first context number is 0. But for readability, this feature was not available when the multi-stage builders came out first. It was added later as an enhancement. So the first context, first stage, then the compilation. My binary is ready. Starting the second context, right? Whatever was created, whatever output was created out of this, it's available in this context as well. Now, how do I say which context? How do I copy? So copy directive has been enhanced to have one more option. You can mention from which context. Part of the file. And that's this regular copy command. Same. Clear? Any questions here?
This would create 2 images.
It will create 2 images. The first one will not be used. You will not see that. We'll see only
An entry point would be used
only this part will be visible. This is an intermediate build used for created for creating this image.
Which version onwards this is available?
1705. I'm using 1706, which came yesterday.
We'll run this new people will run and they build it and compile it and end the 2 operations, right? And then in the run directive, right? We do first the compilation, do it end again the second operation and connect to the next one. At the last, you do whatever you have written to the your image, basically, not the last. So how does this reduce the size? And the first one will never execute, only once it executes.
So we saw the second one, right? The builder pattern. So what we did is we created first one image. We did compilation and we extracted the binary, right? So similarly, this got executed. Everything is ready. My binary is available there. And I'm starting the next context. This one. I just take that binary alone. I don't take anything else from this particular image. Just like the way I extracted from the previous image and top. The Docker gave an elegant way of doing it.
If I do a Docker build, it won't execute those first 4 lines and then it will directly do the
Executes.
So I think what you did was in the initial image you compiled and removed the unnecessary files.
No, it took only what I wanted.
Unnecessary files.
Yeah, exactly.
So basically avoided the unnecessary files.
Exactly.
So this does it in 2 stages and forgets the other.
Yeah.
You only pick what you want to ship.
Yeah. We'll test it.
So after the end of this build, like when we build using this Docker file, you don't even see the builder, right?
We'll see that. I'll execute that.
Okay.
Dependencies it has.
The context. Executed. This was one question, right? Go line. Compilation. What is executing? This part. This is my final image. Now, if I do a Docker images. As good as what I did in the previous step manually. So a simple example, like the one mentioned, like Java and all.
Will it not have the same limitations as the final?
I didn't get that question.
Will this build? You said it should work everywhere, but the shell script it is still limited.
I'm not using shell script now, right? I just executed one
In the
command.
final, you said there will be some limitations. It will not work everywhere.
The previous one, where I use some orchestration workflow above Docker files. Yeah, this one, right? Yeah, I had two different Docker files, and I need to execute them serially.
You need to write a documentation of these files have to go together. Here it's all self-explanatory.
So basically, it is Docker file. This is doing the same thing. Docker file is now because now it supports two.
Whatever we did manually here, now it's being done by Docker file itself. So this is an example from Docker itself. So they have a web app, front end and back end. So first is React.js, compile it. We name the image as the context is stored one, and this one is using a Maven image here to build Java. We call it as app server, and we're using finally one image where we call both the context and copy only what is necessary. It's kind of a production thing. You can see this here in this particular link.
It's also very useful when you want to plug in test pieces in between.
Yeah. So now things are simplified. One Docker file, one syntax. Just need to write Docker file. You don't have to write shell scripts or YAMLs or anything around it. And one build. Yeah. There's a possibility that you run one build and build the other one. I think that's what is going to happen here. And create as many stages as possible as needed. So that's all what I wanted to cover. If you have any questions, please.
Does this work only for Linux platform or Windows also?
I have not tried Windows.
It works on Windows as well. Yeah, with the new Docker framework, right? With the new version, it works on Windows.
This multi-stage is
It's supported. Yeah, it's supported. It's the same API that is being implemented, both for Linux and Windows. Yeah.
and the build image is there, right?
Yeah.
Can we use the same image for every build and only create the shipping part? The next part is there, okay. To ship. We can create a.
It'll get cached if you're using the same steps, right? It'll get cached.
Can we install whatever softwares we require for compilation, right? All those in the same image and use the same one.
Okay.
We can do that.
Same thing. I've used
Unless something changes, it remains the
exactly.
same.
So I've used a ready-made image from Golang. I could create it on my own as well.
One more feature they added is like in the from you can pass the argument also. Now if you have your
You can name it.
you can name your build image and pass it as an argument now, which is very recently added.
So in our case, like Visual Studio, if you want to install software and compile using that, we can have that in the image and then use the.
You can have a compiler image and use it. Any other question? Parallel. It can have. It is a chain basically. If there are 3 stages like the way I showed, right? They have to be dependent. Right? Yes, now the Java example I gave, right? Here, these two are independent, right? Java doesn't depend on React.js and vice versa. But this guy is dependent on both.
You can't run the third one on its own.
What is that?
The third build that you're shipping. It's on its own. The other two you need to have the
Can we run storefront and app server in parallel? Use the build time.
I don't think that's feature.
Yeah, this goes sequentially, right? Like,
Yeah, it's a chain.
it's a single file.
But are they not replicating what Maven and Grad is supposed to do?
Maven and Cradle is running within this, right?
No, I can always say Maven and then build all that, storefront and app server, and then finally I'm supposed to go to deployment and look for doc.
Exactly.
So you need to have a shell.
So we are trying to solve a different problem here.
We're trying to maintain the Maven file and all the relations.
That is what is Maven is supposed to do.
But this is more convenient because it has the same format as what Document has before.
I don't need to know Maven syntax or anything. So somebody has written that container.
Building is not so simple as these two lines. Like
True, but
that is where Maven has come, Gradle has come.
Yeah, so your file will be bigger than this. I mean, when you put it all like
basically what it means is whatever Maven try to do, what build system, they are trying to replicate in some way.
No, they are not doing it.
Maven will do it for you.
No, they're not doing it.
You are running your Maven commands in one of these multi-stage build process. In the second one, you see this is the Maven command which is running, pointing to your form. So you'll get your build and use that build in your third stage.
Maven is
I
like
can
the
within Maven I can call this one the last stage one.
yeah, but how many countries you will have? I mean, everything will go into one container, right? Or do you separate it out? You'll have to use something like this, the previous builder pattern.
You'll have some shell scripting to manage.
Yeah, so first you get React.js, compile it, and then
That's all part of Maven.
So
yeah.
in your case, what will happen is you will have a Maven script, right? Call it document. It's a document. Again, you have
I got your point. So he has done all this within Maven.
See, I
the
can
form
go
itself.
I can go to
Perfect if it works for you, perfect.
Yeah.
It works fine. So we are trying to solve it in a Docker way.
That's good. I want to hear that.
Yeah.
I mean, we are not just using for build, we are also using for multiple things. A lot of things. So we may have to separate out the Docker part.
That's what I'm saying.
I think he's referring to one plugin which Maven provides, which can build
It's in different use.
It's a different in this case.
It's mostly used for interdependent, like there are some dependencies between multiple document files. That's where we're using it.
No, we don't want to ship anything unnecessary. Right?
Yeah.
Thank you.
Yeah.